So practice problem 3, cubic functions, grade 12. Let's go. Here we have a question 9. It says the graph of h of x is equal to negative x cubed plus ax squared plus bx plus c is sketched below. Now we've got a bit of info given to us. A and B is 6 and 0, are the turning points of h. So if we look at it, we don't know what the coordinates of A is, but we have been given B, so let's fill that in on our diagram. Those are the turning points, so clearly we can see that A is the local minimum and B is the local maximum. It says T, which is 3 and Y, is a point on H, so T is just a random point. The graph of H passes through the origin, so it goes through the point 0 and 0. Now, 9.1 says show that A is 12 and B is negative 36. So where this A and B comes from is the equation itself. In other words, they are asking you to get the equation. Now, how this works is for us to get the equation, we need to work with roots. Okay, so we need to know what some of the roots are. And since we have only 2 roots for this particular function, our starting point, and I'm just going to write this as y, our starting point would be A. Well, you guys, might be a bit confusing, but generally how we know it is ax cubed plus bx squared plus cx plus d. But they've changed the letters here. And sometimes they do deliberately do that because they know it's going to confuse you, so they do that. But when we talk about the shape of the function, remember it's always determined by the coefficient of x cubed, which is a negative. So when we start off with this equation, we are going to say negative, and our first bracket is going to represent our root. Our first root is 0. So we can have x minus 0. It doesn't really make sense to say x minus 0, so I'm just going to say x. Our second bracket would represent our next root. We've got a positive 6. I'm going to write that as x minus 6, and I am going to square it. The reason why I squared is because, remember, a cubic function can have at most 3 roots. But whenever we have a root that is a root as well as a turning point, it serves 2 purposes. So it takes on the role of being 2 roots at once, which is why we've got the bracket x minus 6 all squared. Now let's simplify this. So all we have to do here is multiply this out. I'm going to write this as negative x. I've got x minus 6 all squared. We've got a binomial squared. It is going to result in a trinomial. To get the first term, we square the first term. To get the middle term, we multiply both terms together and times by 2. That gives you negative 12x. And to get the third term, we square that second term. So that gives you plus 36. Now we're going to take this negative x and multiply it into the bracket with all 3 terms, giving us negative x cubed plus 12x squared minus 36x. Now what I need you guys to do is match this with the equation that was given initially. So initially what we had was h of x So h of x is equal to negative x cubed plus ax squared plus bx, and there was a plus c. And if you guys match this, you can clearly see here that a, which is the coefficient of x squared, is going to be 12, and b, which is the coefficient of x, is negative 36. And that's actually what they wanted you to get. And here we've got c, but there is no c value, which means that c is 0. That makes perfect sense because remember, in a cubic function, your constant represents your y-intercept. So this cubic function cuts through the origin, its y-intercept is 0, which makes perfect sense why we don't have a constant here. It's actually 0. So now we can conclude and say, therefore, A is 12 and B is negative 36. Now, for 9.2, we need to calculate the coordinates of A. If you look at A, it's a local minimum, which is a turning point. How do we get the turning point? Let's just remind ourselves. In order to calculate the turning points of a cubic function, firstly, we get f prime x. We equate f prime x to 0 and solve for x. And to get our y coordinates, we substitute that x value into f of x to get the y coordinate. Now let's go through that. So we're going to get the first derivative. So first derivative here would be represented by h prime x. And differentiating our first term gives us negative 3x squared. Second term is going to be plus 24x. And third term is negative 36. We're going to take this first derivative and equate it to 0. Now, what I notice here is that all these terms can be divided by 3. So you can go ahead and actually divide by negative 3 so that you can get the x squared to be positive. Alternatively, if that's what you don't want to do, then you can just go ahead and use your quadratic formula. So I know for most learners, you keep away from factorizing because maybe it's something that you don't like to do, or maybe you feel it's time consuming to think of how to do it. So it's perfectly fine for you to use a quadratic formula. Most learners do take that route. If you are going to use a quadratic formula here, I'm just going to go straight ahead and give you your values. The values that you should get is going to be x is equal to 6 or x is equal to 2. Now, referring back to the question as well as our diagram, we needed the values of a. Now, it's excellent that we got x as 6 because that is one of our turning points. So we know that we've done the right thing. But for this question specifically, the 6 is not applicable because we're concerned with a. A is going to be the positive 2, so that's going to be the x value of a. The 6 is not applicable. Let's just conclude and say that, yes, this is a. Okay, but before we conclude, obviously we need to get the y coordinate. So in our original equation, we are going to substitute x as 2. Sometimes it's not necessary for you to show the substitution, but I'm just writing it down so you guys see and know that wherever you have x, you're substituting to. This should give you negative 32 as your y coordinate. So therefore, now we can conclude. The coordinates of a is positive 2 and negative 32. And also, it's good for us to represent that on the diagram. So here we have a. Let's fill that in. Okay, so now we need to get the value of y. So to get the value of y, here's the thing. We've got the x coordinate as 3, and we need the y coordinate. Since we have the equation of the graph, all we need to do is wherever we have x, substitute 3, and we can get y. Okay, so that's quite a basic one. Having the equation of a graph always makes it easier because when you have an x value and you need its corresponding y value, all you have to do is just substitute into that equation. So here is the equation. We substituted 3 throughout. That is going to give you y as negative 27. And since this is 1 mark only, there is no need for you to actually show your substitution. You can just do it on your calculator and go ahead and say y is negative 27. So that's fine. (9.4) says, is the graph of h concave up or concave down at point T? Show all your calculations. So how do we do this? Whenever we talk about concavity, immediately you guys should think about the second derivative. So let that be our starting point. Let's get the second derivative, then we can discuss from there what needs to be done. Now we already have the first derivative, which is here. We are going to differentiate that to get the second derivative. I'm just going to write it here while I can see the equation. Second derivative is going to be first term becomes negative 6x and second term becomes plus 24. Okay, so I've just carried that step all the way down. Now here's my second derivative. And what are we concerned with? We want to know at the point T specifically, is the graph concave up or concave down at that point? Since we know that the x value of T is 3, let's substitute that x value into our second derivative. So we're going to have h double prime of 3. And let's see what we get. Now negative 6 times 3 is 18. Well, negative 18. So you have negative 18 plus 24. That is going to give you positive 6. I want you guys to notice that your second derivative when x is 3 is positive 6, which is greater than 0. Remember, how concavity works is that it works hand in hand with your second derivative. If your second derivative is greater than 0, then it's concave up. If it's less than 0, then it's concave down. We got the second derivative, we substituted the 3, and we've got a positive 6, which shows us that since the second derivative at 3 is greater than 0, that means that at point T, it has to be concave up. So let's conclude. We're going to say that h is concave up at point T. Now we're on to 9.5 and it says determine the coordinates of the point of inflection. So remember how we get point of inflection is we get the second derivative equate to 0 and solve for x. We already have our second derivative, so here it is. So let's just rewrite that. H prime x is equal to, we had negative 6x plus 24. We're now going to take that second derivative, equate it to 0, and we're going to solve for x. So we're taking that 24 over to the right, it becomes negative. We divide throughout by negative 6, so we have x as positive 4. Okay, so point of inflection here, our x value is positive 4. We need to get the y value. How we're going to do this is we take the 4 and we substitute into the original equation. So the equation that represents h of x. Okay, so that's going to be negative into 4 cubed plus 12 into 4 squared minus 36 times 4. That should give you negative 16. Therefore, our point of inflection is positive 4 and negative 16. Okay, so that is it. Second derivative, equate to 0, solve for x. Take that x value, substitute into the original equation, which is your cubic function equation, and that gives you y. So that is our point of inflection. And we are done with this question.